Hello everyone and welcome to our next video on collisions, still under the topic of the conservation of momentum. Alright, so what have we learned so far from the previous videos in this section? Alright, we have shown that momentum in a closed or isolated system is equal to 0. In other words, the individual object's momentum can change, but the total momentum of the system remains constant. Alright, so in other words, if the momentum of the objects change, that does not affect the total momentum of the system underneath the subject or concept of conservation of momentum. Right, so initial momentum will equal PTI, so total momentum of the total momentum initially, and then final momentum will be shown as PTF, which is total final momentum. And the formula suggests there, alright, that the initial momentum should be equal to the final momentum under the law of conservation of momentum, which we have already defined in previous videos. Now, what does the formula mean? The formula means that in an isolated system, the total momentum before a collision or explosion is equal to the total momentum after the collision or explosion. Now, if we are still a little bit unclear on how this is possible, let's look at it through the eyes of a worked example taken straight from the Ciabola textbook for grade 12. And we're going to look at example number 8. Alright, and this question reads, a toy car of a mass of 1 kilogram moves westwards with the speed of 2 meters per second. It collides head-on with a toy train. The train has a mass of 1,5 kilograms and is moving at a speed of 1,5 meters per second eastwards. If the car rebounds at 2,05 meters per second, calculate the final velocity of the train. Wow, a lot of information given to us there. Alright, but first things first. As according to the solutions, we always write down what the question has explicitly given us. So in this question, the information that we can pull out from it is the train's mass, which we're going to take as m1. We can take away the initial velocity of the train as well, keeping in mind that the train is going eastwards. We can pull the car's mass as well, with the car's mass and the car's initial velocity. Car's initial velocity is going westwards, and we can also pull the final velocity of the car, which is going eastward. And what is our unknown? Our unknown is the final velocity of the train. Alright, so now that we know what we have and what we're looking for, we need to choose a frame of reference. Now, step 2, we have to choose a frame of reference, of course, and because east is the most often chosen direction to be positive, we're going to choose east as our positive direction in this question as well. Right, now that we have step 1 and 2 clarified, let's go and do step 3, which is applying the law of the conservation of momentum. So there in the question, again, total initial momentum, PTI, is equal to PTF, the total momentum after the collision. Alright, and we know what momentum is equal to, m1 vi1, so the mass of the first object and the velocity of the first object initially, plus the second object's mass times velocity as well initially before the collision, and that equals to the mass of the first object and the final velocity of the first object plus the mass of the second and final velocity of the second object as well. Alright, subbing in our values there, alright, and our unknown is VF1, which is the final velocity of the train. Alright, we don't know the final velocity of the train, but we do know the final velocity of the car. Alright, and then we sub in our values, punch it in our calculator, and we get an answer for VF1. The final velocity of the train is going at 3.9 meters per second eastwards. Alright? Eastwards. Initially it was going westwards, and now it's going eastwards. Alright. Let's look at another example where we can apply this conservation of momentum just to get it down a little bit more. Alright, so we know exactly what we are dealing with. Let's have a look at worked example 10. This is a bullet question, alright, and this is a question that often comes up in almost all of the examination papers and test papers. Teachers love to set this question because it can be so interesting. But also, if we prepare well, we can also score full marks on this question. So let's have a look here. A bullet of mass 50 grams traveling horizontally to the straight, or to the right, I beg your pardon, at 500 meters per second, strikes a stationary wooden block of mass 2 kilograms resting on a smooth horizontal surface. The bullet goes through the block and comes out on the other side at 200 meters per second. Calculate the speed of the block after the bullet has come out the other side. Alright, so we have our information all in the question. What we're going to do, we're just going to pull it out and write it out nicely for us. So again, step 1, we analyze what we've been given, and we can possibly draw a sketch in this one if a sketch has not been drawn for us. Alright, so in the question there was no sketch given to us, so let us go and draw a sketch. Right, so let's write down what we have been given. The mass of the bullet is 50 grams. Converted to kilogram, it's 0.50 kilograms. The mass of the block is already in kilograms, it's 2 kilograms. The initial velocity of the bullet is 500 meters per second to the right, and the final velocity of the bullet is given at 200 meters per second to the right. Right, now that's the information we've been given. Now we need to find the velocity of the wooden block. We choose the direction in which the bullet was traveling to be the positive direction, to the right. So we choose to the right as positive. And there we have our sketch. Right, so we know the block is stationary, so it's going at 0 meters per second. But after the bullet passes through it, the block does indeed move. We know the initial velocity of the bullet and the mass of the bullet, and we also know the final velocity of the bullet, but we don't know the final velocity of the wooden block. Alright, so again, we plug that into our law of conservation of momentum formula. Alright, m1 vi1 plus m2 vi2 equals to m1 vf1 plus m2 vf2. And we took the bullet to be m1, and we took m2 to be the mass of the wooden block. After subbing in our values, VF2, our final velocity of the wood, was unknown. And once we plug in our values and we rearrange them and punch them on the calculator, we get the final velocity of the wood to be equal to 7.5 meters per second in the same direction as the bullet. Alright, so step 2 has already mentioned step 3 in it, but what you can do is you can further take your answer and say the block is traveling at 7.5 meters per second, and you can add in a direction in there as well, in the same direction as the bullet. The bullet was traveling rightwards, so you can also say the block is traveling at 7.5 meters per second to the right.